We now move on to the question number 4, that is to determine the continuity of function at a given point. The first set of questions is to tell us, for us to explain why exactly it is not continuous. Now, the easy and the simple way is just look at the given x value. They're telling us why does the continuity fail? Why is the function not continuous at the given x values? If you substitute the x value over here, it'll be 1 divided by 1 minus 1. That means it's undefined over there. It's not defined. So basically, there is no point over there. It's undefined. Okay, it does not exist because it's not defined at this particular value of x. You can check the limit as well. Now, what about over here? If you substitute over here, it's discontinuous. You'll come to know there is an asymptote, vertical asymptote. So if there is, whenever the denominator becomes undefined, basically it's not continuous. That's it. That's simple as that. Okay, we are not finding the limit over here. It's not, our intention is not to find limit. Even if the limit exists, that doesn't mean that it's continuous. It's discontinuous because, there is a vertical asymptote. If you have vertical asymptote or jump discontinuity, then it is not continuous. Even over here 1 by x, what happens? It'll be undefined, right? And lastly over here, see, at x equals 0, what is e to the power 0? It's 1. So in the denominator, you do not even need to look at the numerator. This is fine. E to the power minus 1, there is some value. It is defined in the numerator. But denominator will be 1 because e to the power 0 is 1 minus 1, that's 0. So it's not defined. It's very straightforward, the first part. And over here now, they have given piecewise equations. That's fine. Now, how do you find the continuity? Basically, in order for a function to be continuous, I'll write it out over here. There are two conditions. First, the limit as x tends to this particular value 2 from the left side must be, this is f of x, okay, must be equal to limit as x tends to 2 from the positive side for that same function. Okay, now this is the thing. And if this exists, this is true. If this is true, if this is false, over. It's not continuous. But if this is true, then whatever we get, right, the limit as x tends to 2, it'll be the answer. If this is all, see over here. Now, as limit 2 from the negative side less than, what is the answer? X squared. So let's substitute over here x squared. Instead of x, we have 2. The 2 square value would be 4. Same thing from greater than, plus means this one. Let's substitute over here as well. 3 into 2 minus 2, that will be also 4. We got 4 and 4. Therefore, what is the answer? Limit f of x would be 4 here. But this is not over. This must be equal to f of this given point, f of 2. See, whatever the limit is there, right? This is the y value basically. This is the y value. If there's a graph, you're going to get, now imagine this is the graph, just a rough figure. It is not correct. But anyways, so imagine like this. At 2 it was. So imagine this is x equals 2. This point is at 4. Okay, now what happens? F of 2 means you're finding what is the y value directly from the function at the x value 2. It must be same. It must be coinciding with this. Otherwise it is not continuous. That means otherwise there's some jump discontinuity, Now look over here. F of 2. What is the function f of 2? F of 2 is given as 3 here. Can you see? At x is equal to 2. What is the answer of the function? It is 3. Which is not equal to 4. Therefore, it is not continuous. This, yes, over here it's correct. Very good. The limits are true. It's 4. But look at the function. At 2, it is not. That means, now imagine the function is something like this. At 2, right? So I will consider this to be the point 2. Here you can see the graph is coming something like this. From here also it's coming, but this is coming at 4. Look, this is the value of 4. But exactly when you reach this point x equals 2, there is a hole over here. Why? Because the point of x equals 2 is at 3. This is the answer. There's a jump. So this is the answer. So this is what this particular graph would mean. Because from left side, you're closing in on the value number 4. Right side, yes, 4. Limit exists. But now, because we have been given at exactly f of 2, what is happening? The value is 3. It's not 4. Here we get 4. Here we get 4. But you can see over here it is 3. It's not 4. Therefore, it is discontinuous. I hope that is clear. You can see your left side is 4, right side is 4, but at that particular point it's 3. Now, the limit, this limit at x equals 2 is not equal to f of 2. Therefore, it is not discontinuous. Now, what about this one? Okay, you have less than. Let's substitute over here. So if you're finding the limit, same thing, limit x2 minus, that would be, substitute over here, 2, it'll be 2 square, that is 4. Here it'll be 3 times 2 minus 2, that is also 6 minus 2 is 4. Yes, but did they define anywhere it's less than or equal to here? Can you see, is it less than or equal to? No, that's never defined. So that means we cannot tell, we don't know this particular part. See the middle part, right, which was given, that's not at all there. So we don't know. It's discontinuous because it's not at all defined at this particular point. So we cannot conclude it as continuous. We just tell it's discontinuous because it's not defined at x equals 2. That's the reason. So we cannot find f of 2 in this case, in the second problem. Now comes the interesting part. Okay, we need to find the intervals where they are continuous. I realize that the answer over here is kind of wrong. It's a closed interval over here. This is also closed interval. I just realized it. But anyways, now let's see how exactly we solve it. See this particular part, there are many ways to solve it. There are theorems, use the theorem again and again, check whether it's continuous, like long theorems, you know. But what I would suggest is, I usually follow this method and it works almost all the problems. So look at the question and understand the question first. We will do this first. Is there any denominator? No, it's just a square root function. It's just a square root function. So just focus on its domain. What's the domain? Greater than or equal to 0, because this particular function will be defined at the corners. In fact, to find continuity, there are two separate theorems. There are things you need to memorize. If it's polynomial continuous every way, if this is the case, it's greater than 0, then you need to use another theorem and check the limit at both the sides. Now imagine this, you must check these 2 points. Less than, if it is, valid over here and over here, then we will use less than or equal to, it will be a closed interval, otherwise it's an open interval and all that. It's very confusing, but now I'll just directly tell you a shortcut method, because anyways this will be MCQ, right? What you do is look at the function. If there is no denominator, just like this, consider the inner part, just find the domain of this. X plus 3 must be greater than or equal to 0, isn't it? So x, 3 goes to the other side, must be greater than or equal to minus 3. So it'll be negative 3 comma infinity. That's the answer. It is continuous over here, all this part. But what about elsewhere? So now this over here must be, sorry, let me just go back over. It must be a closed interval here. Now, what about that's the thing. What about the other parts? If it is less than negative 4, say if it's negative 4, let's substitute over here. Square root negative 4 plus 3, what happens? It's a root of negative 1, which is an imagined number. It's not in the real number domain. So this is the thing. The second problem, how do we do this? I hope you remember how to solve the squares. This was taught in grade 11. You can see some of the videos in grade 11 term 1, because I have already explained this. You can find detailed explanation of that. Grade 11 term 1, you have to study this about inequalities. Okay, how you basically do it is, whatever is inside the square root must be greater than or equal to 0, right? Okay, that's fine. Now, how would you solve this? You cannot directly take this to the other side and solve. It would be an error, because you will have two values. It will not, you won't understand that exactly. So what you do is, you solve it as equating it to 0. So you equate x square minus 4 to 0. You can use quadratic mod phi 3 in your calculator and solve, but since this is a perfect square, I'll just take 4 to the other side and now take square root on both the sides. What am I going to get? I'm going to get x equals plus or minus 2. So this is the answer. Now you need to draw an interval like this. You need to draw. So it should be proper. Okay. And what are these points, x values you found out? See, there's no denominator or anything. It's just these values, minus 2, 2. Now, these are intervals. See, from here to here, it's all the values between minus 2 and 2. If it's over here, it should be less than minus 2, that is up till minus infinity. And if it's greater than this, it's positive infinity. Okay. Now, these are the cases. Here, you need to choose some test values. Whenever you have 0 as a test value, where is 0? It falls over here. Choose that. Even you can choose 1, 2, 3, anything, it's fine. It will be the same thing, okay? Here, choose a small value. Don't go to big values. I usually choose just next to these, okay? Even if I take 100 or 1000, I'm going to get the same concept. It's going to be either true or false. It's going to be same, any number. I'll show you also in a while. So now this is the diagram. Here, these are the test values. What are you testing? Since it's inequalities and since there is square, we are not sure which interval is true. So we use this given question to test the values now. What do I mean? Whatever is inside the square root greater than or equal to 0, right? This over here, let's take it. X square minus 4 must be greater than or equal to 0. Now apply this test value over here. I'll put this test value inside x instead of x. I'll put this 0 minus 4. 0 square is 0, minus 4 greater than or equal to 0. Is it true? Minus 4, is it greater than or equal to 0? No, it's false. Wrong. Same thing now. Try the other test values. Let me put minus 3 instead of x square. I'll put minus 3 the whole square minus 4 must be greater than or equal to 0. What about minus 3 the whole square? It will be 9 minus 4 greater than or equal to 0. Yes, phi is greater than or equal to 0. This is true. What about the right side? It's going to be same because you know if you substitute positive, negative or positive 3, when you square it, it's going to be positive. It's going to be 9 minus 4. But now what if instead of this, I'll take another value, test value. Anything greater than 2 is open to test. So I'll choose a test 10. Why I'm doing this is I'm just proving that you can choose any value. Once you find the x values, you can choose any point in this range from 2 to infinity, because there are only a 2x values, plus or minus, minus 2, 2. So you'll get 3 regions, 1, 2, 3. Any single point within this, even over here, you can take it as 1. So if you put 1, it will be 1 square. 1 minus 4, it's minus 3. It's not greater, it will be false itself. Now last one over here, let me just take 10, the whole square minus 4 must be greater than or equal to 0. 100 minus 4 must be greater than or equal to 0. Yes, 96 is greater than or equal to 0. True. Now, why do we do this is to find what is the intervals or the domain intervals. Now, basically what we found is all the intervals over here is true, this is wrong, this is true. That means the answer for this basically is from minus infinity to minus 2. Now, since it's greater than or equal to, we use the close bracket, and from positive to infinity. Whenever it's infinity, we always use the small bracket, that is open interval. This would be the answer. You can see over here, I apologize again, it should be closed interval, big brackets. The intervals are very, very crucial. Closed interval over here will be like this and like this. I hope this is clear now. So that this concept is really important. Okay. Now that's how we find the test values, and that's the thing. But always remember, when you have x squared minus 4, because this might come often greater than or equal to 0, remember it's all the values less than negative 2 till infinity and from 2 to positive infinity. Anything within this does not work. Okay. Now what about a cubic? See, cubic, it's literally all real numbers. You don't have to worry. Now, only when it's square root, it's a problem because there might be some values like negative values, you can't get a square root, right? But if it's cube root or any odd power, if it is 5, 7, 9, then it is all real numbers. It's basically continuous everywhere. That means all real numbers, negative infinity to positive infinity. Whereas if it is even numbers, even power roots, 2, 4, 6, 8, 10, then you need to do this. Interval. You need to be cautious. It must be greater than or equal to 0. What about this one here? Now, this is again tricky. It's not tricky, sorry. Just rewrite it, arrange it, and rewrite it. How do we write this? Whatever is down, that means that's the square root. What is down is over here. What is up is basically on them. We know for cube it's all positive everywhere. But what is the problem here? Since there is a square root, you need to understand that x minus 1 should be greater than or equal to 0. Okay, so this is the only concept over here. Now what happens? It will be greater than or equal to it's greater than or equal to positive 1. Yeah, minus, sorry, this is minus 1. Take it to the other side, it will be positive 1. Here just remember, if there is nothing, that means there's 2. Okay, this 2 I mentioned because it's given over here, but if it's nothing, it's already 2. And also you can write this x plus 3 whole power half. That's the same thing as square root. So that would be the answer for this one. It's basically, take this x equals to 0, I mean greater than, you just take it to the other side, becomes positive, so it's 1. Now, sine inverse. This is a bit tricky. What is the answer for sine inverse? First of all, what is exactly sine inverse? Um, Now, we know sine theta, right? Say sine theta is equal to any value. Let me take it as x plus 2. Okay. If you take sine inverse on both the sides, sine inverse sine theta, that is equal to sine inverse of x plus 2. Okay, this cancels and theta equals sine inverse of x plus 2, isn't it? Now basically whatever this you see over here, x plus 2, is equal to sine theta. Why? Because now if you understand like this, because whatever is over here, imagine it is equal to sine theta. Now take sine inverse on both the sides. This sine cancels. You're remaining with theta and sine inverse of x plus 2. So this is the thing. So what this value is, x plus 2, is basically equal to sine theta. So what is the domain of sine theta? Sine theta graph, we know it's like this. It starts from 0, it goes on like this forever, right? Now here from 0 to 2 pi, it's the period, but that's all not required. What we know is the range. What's the maximum and minimum value? It's plus 1 and minus 1. So the range is always given. Sine theta can only have answers which is less than or equal to 1 or greater than or equal to minus 1, right? That's the thing. Now here, what is the thing? We have, instead of sine theta, x plus 2 less than or equal to 1, less than or equal to minus, greater than or equal to minus 1. Now we need to find the x, right? What is happening for x, not only not x plus 2. So we know this will be within this range. So what you do is just subtract 2 everywhere. Why? Because I want for x not exactly x plus 2. So what you do is minus 1 minus 2 less than or equal to x plus 2 minus 2 less than or equal to 1 minus 2. What's happening here is minus to minus 3 less than or equal to, this cancels, you're remaining with x less than or equal to minus 1. So this would be your answer. It is in the range minus 3 to minus 1. Can you see that? Continues on the interval. So whatever happens, remember, whatever is the sine, when you have sine inverse, even for cos inverse, it's the same thing because it's always 1 to negative 1. Just whatever is given over here, you need to put like this. This value in the middle, It should be less than or equal to 1 or greater than or equal to minus 1. And then you need to solve for x, find x. Now here, since it's plus 2, you need to subtract everywhere by minus 2. Directly looking at this, I can guess, okay, I know it's going to be, this is x plus 2. So subtract, what should I do to get x? I should do minus 2 on both the sides. So I know negative 1 minus 2 is minus 3. Over here 1 minus 2 is minus 1. So that would be the answer. Now here it's closed brackets because it is less than or equal to. That's, it's just all the domains, it's understanding a bit. Now what about this one here? Okay, this is a little bit tricky. um okay, I'll just try it anyways because it's sine inside of lan. Now that'll be like periods and all that stuff. You should understand what's the period, where it is positive, negative. Anyways, let's do it now. I will just clear these other questions. We are doing the last one, 26th in this. Oh, sorry, it's not the last one. There's two more. But anyways, in this page, the last one over here, what we do is, first we need to understand where is natural logarithm defined. This value over here, whatever is the value, if it is x, should be greater than 0. It can't be 0. You can try, test it in your calculator. Take out your calculator, put ln of 0, you will get a math error. If you put ln of negative 1, you will get math error. Let me just do it. Let me do it in the calculator and show it to you. Over here, this is the natural logarithm. Now let me put 0. What is happening? It's a math error. What if I take it to negative 2? Again, it's math error, any value. But what if it's positive? You have an answer. Okay, even if it's just teens a little bit more than 0, you have an answer. Okay, but if it's completely 0, no answer, it's math error. So that's the domain. Now that's why you should know it's not just greater than or equal to 0, it must be 0 whatever is the value. But now we don't have over here x. It's not x, it is what? It is sine x. So sine x must be greater than 0. I wish it was some x or y. It would be very easy, that's it. But now, when a sine x equals to 0, you need to find all the possible values when sine x equals 0, right? Because this is the domain. Now what you do is, let's see the graph again, sine graph. It starts from 0, it goes like this, and it ends at pi. And then it comes down like this. It should be, same. Let me just try. Okay, still it's not the same, but anyways, it's 2 pi. Then again, it'll go up like this, and it comes down. It's over here 3 pi, and then it will be 4 pi, and it's so on. This is the sine graph. The difference between sine and cos graph is it's just sine starts from 0, 0, x is 0, y is 0, whereas cos starts from here, and then it goes like that. Okay, let me just remove that for now. Now we're just dealing with sine. So this is the answer. Now what are the answers? This is our answer. See all this region, right? From 0 to pi, from 2 pi to 3 pi. But we can't keep on writing because it goes, see, 0 to pi, one answer. Then 2 pi to 3 pi. Okay. Then what is the answer? It is 5, sorry, it's 4 pi. 4 pi to 5 pi. Then 6 pi to... It's crazy, right? How do we write it? We need a form. So what do we generally do is we don't start with 0. We use the coterminal. Coterminal angle is basically if you have, say, 0 degrees, add 360. Even minus 360, that's also a coterminal. That is 360 degrees. This is degrees. In terms of radian, it is 2 pi. Okay. Now here you can see this is 2 pi. We know this is positive. So let's use this as standard, 2 pi. Now I can't write 3 pi because that doesn't make sense, right? Because I can't keep on writing 2 pi plus 3 dash 3 pi like this. It can't be repeated. So let me write this also in terms of 2 pi. What I mean is, from here to where, again it's 2 pi plus pi. Is this okay? Why did I write like this? Because I know here, if I start at 2 pi, all the next values of sine until the next pi, that means 2 pi plus pi will be positive. So 2 pi to 2 pi plus pi. because this is positive. All the see now over here 0 to pi, right? So I should just do 0, comma 0 plus pi. But now this wouldn't be making sense because 0 is there. Now first value is like nullified. Now here it makes sense because now if I write say n, and over here also n, what does this mean? 2 pi n, comma 2 pi n pi plus pi. Now this is my interval. This is the interval where I which I want. What does that mean? This means that n is any integer. Integer why? Because integer is whole numbers like minus 1, 0, all negative and positive numbers, right? 1, 2, 3. Now imagine if I tell n is integer, then I'll just erase this. If I use any value, say I will use n as 0, then what am I going to get over here? N is 0, so it will be 2 pi 0, comma 2 pi 0 plus pi. So the interval would be 0 to pi. Yes, that's correct. Now what if I put over here 1? Then I'm going to get 2 pi, comma 2 pi plus pi. That is 3 pi, isn't it? 2 pi, comma 3 pi. Yes, that's correct. From 2 pi to 3 pi, it's defined. Now what about if I put 2 over here? Then I will get 2 pi times 2 comma 2 pi times 2 plus pi. That would be 2 pi times sorry, this one over here, yeah, it's done correct. This will be 0 0, yeah, and pi remain. So sorry, back over here, I just got distracted. 2 pi, 2 times 2 is 4 pi, and this is again 4 pi plus pi is 5 pi. You can see I am getting all the positive domain of sine x. So this is why I write this as this. Okay. Now, if you're thinking, how can I do it in short? It's just that don't start with 0, start with the. Now, you should see which is the first positive value. I know it's 0 and pi, right? So the coterminal for 0 is 2 pi. I know that. Why? Because you just add 2 pi, 360 degrees. That is 2 pi. So start with 2 pi till where it goes. From 0 till pi. See how much is the distance from here to here? It's pi. So the next one will be the same thing, but you should write plus pi. And don't forget, the first part, only the first parts will have the integer. Okay, that is any integer. So this is how the answer over here should be 2 pi n, comma 2 pi. It will be like this. This is the answer. Okay, let's just check the answer. Okay. It's just given k over here. See, it's not integral, it's integer values. Okay, this should be integer values. I'm sorry, there are some errors in this. Um, integer, okay, integer. Now, this is true. Why? Because, this must be greater than 0. Sine x must be greater than 0. So you can't have a closed interval. Now, if you're wondering what happened over here, let me show you. What did I tell? It is 2 pi n, comma 2 pi n plus pi, isn't it? This is the answer. But here they have simplified it. Instead of n, that is k. That's fine. It can be any number, okay? It depends on the option. It won't be x and y, but it'll be a, b, like that. Generally, n or k is used, okay? Now here, left side is same. 2 pi n, it's fine. 2 pi and k. Comma, here the pi term is removed common out. You're using distributive property. So you're remaining with 2n plus 1. Then what is removed out? Pi is removed out. But now look, if you multiply this inside, you're going to get the same thing. It will be 2 pi n plus pi. Now if you multiply over here inside, you're going to get same thing. It will be 2 pi k plus pi. That's the thing. It's distributive property. You're removing a common term out. Basically, that's called distributive property, common factor removal. That's the reason why it's like this. But remember to mention that k is integer values. Now you must select the correct answer. So that's the thing. That's about this. It's a bit lengthy. Like to understand each one, it's different. It's not the same concept over here. Now we go on to the 27th problem. Here, again, it is simple, it's straightforward. It's just that there are two things. One is the denominator, one is square root. I'm sure you know how to individually solve the square root, how to individually solve the denominator. Now, here, what you do is see the square root, right? x plus 1. Whatever is inside the square root must be greater than or equal to 0, isn't it? So this is greater than or equal to, sorry, let me write it down. This term inside it, x plus 1, must be greater than or equal to 0. So x must be greater than or equal to negative 1. This is the continuity term. So it should be continuous anyway from negative 1 to infinity. I hope this is clear. It will be open interval for infinity. Now this is the answer. This is continuous everywhere. But look at the denominator. There is a denominator. Whenever the denominator is 0, it's undefined over there. That's a problem, right? So let me just erase this. See, the first part of the question is found out. But what about over here, right side? This is important now. Look at this. X squared minus 2 cannot be equal to 0. It cannot be equal to 0. Okay? So let's solve that. X squared cannot be equal to positive 2. Or what about x squared equals? X would be not equal to plus or minus square root 2, right? Take square on both the sides. It will be plus or minus 2. Okay, but look at the answer. It's only plus 2. Why there is no minus 2? I will reiterate this. What if I put over here in the denominator root 2, positive root 2 minus 2, it'll be 2 because square root and this cancels, minus 2, that's 0. What if I put negative 2 root 2 whole square minus 2? You can try this in calculator. This cancels, but the square will dissolve this negative sign as well, right? So you will be remaining with 2 minus 2. What is the answer? 0. Then why don't we use it? Can you think for a while? Answer is over here. What is the value of square root? Square root 2, sorry. Okay, it's 1.4 something, right? I guess so. It's somewhere near over there. Oh God, I can't remember it exactly. Anyways, it's around there, I believe. Now, positive plus or minus means 1 is positive value. Now, negative root 2 would be negative 1.4. Negative 1.4 is not there in this interval in the first place itself. So that's why we have only positive root 2. That's the reason, okay? So don't consider it to be plus or minus. It'll just be positive root 2. Why? Because we already found the continuity over here. Whenever this should not be equal to root 2, okay? That's the thing. Just for understanding. And the last one over here. See, whenever I see squares, I know this over here. What is it going to be? It should be x squared minus 1 greater than or greater than only, not equal to, because it's natural logarithm. You can't have 0. It should be greater than 0. Now, what happens? Remember the interval. So looking at this, I know it's going to be x squared minus 1 equals 0, x squared equals 1, x is equal to plus or minus 1. Okay. Now here the two values, minus 1 plus 1. Let's take the test value 0. Let me take over here 2 minus 2. Let me substitute over here. First, let me substitute minus 2 the whole square. Sorry, whole square minus 1. That must be greater than equal to 0. What happens? Minus 2 the whole square is 4 minus 1. It should be greater than 0. It's 3. Yes, it's greater than 0. It's true. So this is true. I'll just put a tick. Next, put 0. 0 square is 0 minus 1 must be greater than 0. Minus 1 is greater than 0 is wrong. This is wrong. No, that doesn't work. Let's take the next one. What if it's 2 square minus 1 greater than 0? Yes, it is 4 minus 1 greater than 0. 3 is greater than 0. It is true. So these are the intervals, okay? So you can see it's till minus 1. And then, over here, I just forgot about the denominator. How can I do that? Now, anyways, let's just quickly see. I hope this is clear. The first part over here, we got continuity of, let me just write it, minus infinity to minus 2. Okay, this is open interval. And we got from 1. Sorry, this is minus 1. What am I doing? I'm just getting confused because I took, let me write this. See, this is the x value, right? It's still minus 1. And over here it is 1 to infinity. What about the other thing? This one also needs to be found out. This also needs to be continuous, right? Solve the same thing here in the denominator. But just be careful. It should not be less than or equal to 0. It should be only, sorry, it is not greater than or equal to 0. It is only greater than 0. Why? Because it can't be equal to 0. It will be undefined as well. So the same thing what we just now did, do over here as well. Now in there you will see that this will be removed. I'll just show you. See the first part, I'll just show the answer over here. This first part is correct. Now why this 1 comma infinity is not there, I will now tell you. Let me just write it out over here. It was minus infinity comma minus 1 and 2 sorry, it was not 2, it was 1 comma infinity. Now let me do this one. It will be x squared minus 2x greater than 0. So how would you do it? You can take it to the other side, make it equal to, or you can just use the calculator. It's much easier, right? So let me just use the calculator over here. I'm a bit lazy now. Here we have to just press mod 5 and 3, and now it's 1 minus 2 and 0, so that you know it's 2 and 0. Okay, we got the two values, 2 and 0. So let me use them. X is equal to 2 and 0. We have to do the interval 0, 2. This test value would be 1. Over here, what is the test value? It can take it as 3. Let me change the color, sorry, so it'll be much easier to understand. The test values are 1, 3, and minus 1. Now substitute these values in the inequality over here. That is this inequality, okay? So let me put minus 1 the whole square minus 2 times minus 1. It must be greater than 0. What is the answer here? It will be 1. Minus of minus will be plus 2 is greater than 0. Yes, 3 is greater than 0. It's correct. This is correct. Now let's go to the next one. 1 square minus 2 times 1 must be greater than 0. It's 1 minus 2 greater than 0. Negative 1 is greater than 0. It's wrong. This is wrong. Let's try the third one. Over here, I'll put 3 square minus 2 times 3 is greater than 0. It's 9 minus 6 greater than 0. Is it true? Yes, 3 is greater than 0. Yes, this is correct. So here we come to know one important thing. The intervals are from minus infinity to 0, but we already got the interval till minus 1. So look over here. Let me just write the intervals which works over here, and from 2 to infinity. Now compare, because both of them must match. You can't just take this one or this one. Now it's very close over here. See, minus 1 and 0. So if you remember in grade 9 in that inequality we graph, right? If you have two things, we used to do one thing. What is that? We used to see, compare. Okay, this is minus 1, this is 0. So from 0, it's the solution. But in this case, it's not like that. Here, we are very, very careful about which values we choose. Okay, that is very important. We can't choose, if over here, you can have anything till minus 1. And here the 0 value is not at all included, but here 0 value is included, which does not make sense. This is okay. Take the lesser value, because over here 0 is not included. Don't take this. Take this one. Why? Because over here they're saying all the values from here is possible. One more thing is saying all this value is possible. Now if you choose this answer, the minus 0.5 is not possible for this range, so it will be an error. So if you put over here minus 0.5, it will be an error. It is not continuous at that point. So don't take that overlapping. Only this region can be taken. Why? Because minus infinity to minus 1 is true in both the cases, right? Only this part you ignore. This part you ignore. That means we are not going to take 0. We are going to take this value over here. Now, what about 1 to infinity? Same thing. We have 1 over here. So imagine this is 1 to infinity, right? This is true in this case. But now in the next case, it says 0 to 2 is wrong. So 1 is not defined over here, but 2 to infinity is defined. So don't take this, because over here you can see 1 to 2 is undefined in the second part. So you just choose the second one. So the answers would be negative infinity and minus 1 and 2 to infinity. You can check over here. Yes. See, this is the thing. It's from minus infinity to minus 1 and 2 to infinity. That would be the answers. I know it's a little bit complicated, this part. I hope you'll get an easy problem, a direct problem. But if you get like this, try to do it when you have plenty of time. Don't spend too much time if you're getting confused on this. Try to do it for the last, but understand the domains. Whenever you see a square root, whenever you see ln, you need to know when it's a square root what. When it's square root, you must use greater than or equal to. When it is ln, you must use greater than 0, greater than or equal to 0. Now, what if it's in the denominator? Then it should be not equal to 0, okay? But now in this case, it's in the denominator, square root and denominator. So you can't use greater than or equal to 0. Why? It should be greater than 0, because greater than is fine. It can be anything greater than 0. But if you're writing this equal to, it would make sense. It would not make sense. It's undefined at 0. Denominator cannot be. So if you see square root and something over here like this, so in such cases, it should be greater than. Otherwise, whenever you see square root, it's greater than or equal to 0, and so on. So you should just remember the domains. If it's sine, so we have already done that. So please make sure you understand that thoroughly, and then you can solve any problem. So that's the end of these topics. I know there were short number of topics over here, but they are a bit tricky. Please try to go through them thoroughly. And if you have any doubts, do post them in the comments. I'll try to get back to you soon. See you in the next question.